Hey, and welcome to the lesson on congruence in overlapping triangles. Our essential question and objectives. What is special about the congruence in overlapping triangles? So we're going to look at properties of overlapping triangles and use those properties to prove congruence. Our standards: use congruence and similarity criteria for triangles to solve problems and to prove relationships in geometric figures. Construct an equilateral triangle, a square, and a regular hexagon inscribed in a circle. And prove theorems about triangles. Theorems include measures of interior angles of a triangle sum to 180 degrees. Base angles of isosceles triangles are congruent. The segment joining midpoints of two sides of a triangle is parallel to the third side and half the length. The medians of a triangle meet at a point. So when we talk about overlapping triangles, you're usually going to see a shared side or a shared angle. And a shared angle might look something like this. I have a triangle here and a triangle here, and they share this angle. Something like that. But usually if there's a shared angle or a shared side, that means those two triangles are congruent. And so we're going to look at how to prove that these triangles are congruent. First, we're going to separate the triangles. That's the first most important part, so that we can clearly see what triangles we are talking about. So first, we have triangle ZXW. So I'm going to redraw that over here. Okay. ZXW. And then we have triangle YWX. And it's important to draw them separately so that we can see them as two separate triangles instead of one figure. Okay? So given to us is that ZXW, which is this angle right here, is congruent to YWX. So that's congruent to this angle. Next given to us is that ZWX, which is this angle, is congruent to YXW, which is this angle. Okay, so we have two angles. And so I'm going to start my columns right here. So statements, and then the reasons. I'm going to start with my givens. Okay, so my first statement is that angle ZXW is congruent to angle YWX. That's given. And then angle ZWX is congruent to angle YXW, and that's given. And then I can also say that by the reflexive property, WX is congruent to itself. WX, whenever something is congruent to itself, we call that the reflexive property. Now, remember what I'm trying to prove. I'm not trying to prove that the triangles are congruent, but I'm trying to prove that ZW is congruent to YX. In order to do that, I have to first prove that the triangles are congruent, and then I'm going to use CPCTC. So, by angle side angle, triangle ZXW is congruent to triangle YWX. By angle side angle. And finally, I ran out of room here, but if we go up here, I can say that excuse me, ZW is congruent to YX. Why? Because corresponding parts of congruent triangles are congruent. Okay, here's a look at your assignment for this lesson. Looks like you're going to start off reviewing common sides of overlapping triangles. Little vocabulary builder. What does overlapping mean? what is the adjective and what is the noun. You're going to use your vocabulary a little bit to answer some questions. Then you're going to get into some problem solving, identifying common parts, using common parts in proofs. Just follow the directions very closely, and then you're going to complete some proofs, incomplete proofs, one step by step. And then you're going to be using 2 pairs of triangles to even extend and further certain proofs, and get even more into depth about separating overlapping triangles as well. If you need any help, feel free to reach out to me on BBIM, text message, phone call, email, whatever's easiest for you. I'll be in the Math Cafe Monday, Tuesday, and Wednesday at 11 a.m. You can meet me in the live session. If you need more help than that, you can go to Math Cafe from 9 to 3 every day. There's a math teacher in there willing to help you with your assignments. Like I said, if you have any questions, reach out to me. I'll see you in live class, and we'll talk to you later.